The question 3 is going to be about the estimating of the friction angle beta. And then if I can find the beta, I will be able to find the value for the coefficient of friction. So let's see how we can find that. Let's go back to the question. And as you remember that we do have the value for the alpha, and we do have the value for the TO, and we have the value for the TC, and this will help me to find the value for the phi, which is 25.4, and I need to find the value for the beta, and let's see how we can find that. For this question, we need to calculate the friction angle and the coefficient of friction, or the beta and the mu. You remember that the mu is equal to the tangent of the beta. So let's go to how we can find the value for the beta. We have, well, something like we call it merged equation. So of all the possible angles at which the shear deformation can occur, the work materials will select the shear plane angle, phi, that minimizes cutting energy. So the lower value for the phi is going to give me the higher value for the phi is going to give me less energy during the cutting operation. So the equation that we can find say that the phi value should be equal to 45 degree plus the alpha divided by 2 minus beta divided by 2. This equation derived by Eugene Merchant and is based on the orthogonal cutting, but validity extended to a 3D machining. To increase the shear plane angle, and the higher shear plane angle definitely is going to cause less power and less forces for the cutting, we need to increase the rake angle alpha and reduce the friction angle beta. And this can be done simply by reducing the coefficient of friction. In the Merchant equation, we assume that the shear strength of the work material is going to be constant. And this will be unaffected by the strain rate, temperature, and the other factors. So let's go back to the question and do the calculations. Okay, so let's go back to the question. We said that we do have a cutting tool rake angle alpha as given as the value for the 10 degree, and we have that the chip thickness before the cut was 0.5 millimeters, and the chip thickness after the cut was 1.125 millimeters. We're going to use these parameters in order to find the value for the beta, which is the friction angle, and the value for the coefficient of friction, which is the mu. So the step number 1, we calculate the value for the R, if you remember in the first part, the question 1 for this week, and it was 0.444, and then we use it to calculate the value for the phi, and it being found to be 25.4 degree for the phi. Now we're going to use Merchant equation. So remember the Merchant equation, let's see what the parameters we have and what doesn't. We have the value for the phi, we have the value for the alpha, but we don't know what the value of the beta, so we need to rearrange the equation to be beta is equal to 90 degree plus alpha minus 2 phi. Put the parameters in, and we will end up finding the beta to be equal to 49.2 degree. Now I know the beta, I can simply calculate the coefficient of friction, which is going to be a tangent of this beta. And the mu now is equal to 1.16. That's quite high value, by the way, if we're going to say that the coefficient of friction, but just remember that this is not friction between basic two surfaces, but it's going to be between a cutting tool and the chip value. Okay, so thank you, and we're going to continue with the rest of the questions.